title of her presentation is Studying the Level Effect in Conjoint Analysis, an application of efficient experimental designs for hyperparameter estimation.
Okay, well, again, thank you to the organizers, all four of you, for inviting me to this workshop and the conference. It's been a very interesting few weeks. So control L, yes. Where is it? Thank you. So this is work that I did some years ago with Greg Allenby from the marketing department at The Ohio State University and our joint PhD student, Ching Liu, and also David Barkan from Harris Interactive. Those are the people who run the Harris poll. So the outline of the talk, you've already had an introduction to conjoint studies, so I'll go over that very briefly. One of the things that I keep hearing in the marketing area is this idea of context. It took me a while to understand what contexts were, but it'll be obvious as I go through the talk. We used a Bayesian hierarchical linear model and developed a criterion for estimating the hyperparameters of the model. Then we wanted to model the level effect, which I'll describe, and the reason was we wanted to predict a new context, which I'll also describe. And I'll show you some of the designs that we used and a web-based survey. So you've already heard about the fact that conjoint studies are widely used in marketing to study consumers' preferences for different products, and in particular to find out which features drive their preferences. And again, as both Brad and Martina have been talking about, the product features are called attributes. So in our case, we're going to be talking about credit cards, not laptops. And one of the attributes will be the interest rate. And so the levels of the attribute might be something like this. The combinations then of the attribute levels form the product profiles or alternatives. And respondents evaluate a set of product profiles, as Martina said earlier, using maybe different methods of evaluation. And both Brad and Martina have been talking about choices. I'm going to be talking about ratings. And then the evaluations are used to estimate the average of the part worths of the attribute levels. In other words, they're really just contrasts between the levels of the attribute. And those then help to explain which particular attributes are more important to the consumer in the way that Brad was describing. Okay, so here's a view of the screen that we used in one of our surveys. I'll come back to this later, but for the moment, just want to show you these are 6 different profiles here. There are 3 different attributes. The first one is interest rate, and that's at several different levels. This second one is the provider of the credit card. There are 2 levels for that. And the third one is rewards, travel rewards, cash rebate, or no rewards. So there's 3 levels for that attribute. Then we had a panel of experienced respondents, so it was possible to show them a screen of, there's actually 12. This is the bottom 6, there's 6 above it. And these respondents had the experience to be able to rate that number of profiles. So they put their rating in the boxes down below. Okay, now consumer preferences are context dependent. And by context, as Brad showed, demographics might have a big effect. In his study, he had an effect of gender. You might have put in here age, household income. Purchase environment is a context. How many different choices do you have when you're in a store? If you've only got 2 different brands of cornflakes, then it's pretty easy to make a choice. And maybe price doesn't seem quite so important. You can just focus on the difference between the cornflakes. But when you get into a big store with 20 different varieties of cornflakes, I don't know how you feel, but I think, oh, forget it, I'll go and get something different. Then consumption environment. you're going to buy a new car. What do you want the car for? Do you want it to make short trips to the store? Do you want it to travel for work? Do you want it to go on holiday? So those are the consumption environment. Okay, and so we can take a matrix, Z, and put the context somehow into that matrix. So if the context are demographics, you might put in, say, the age and the household income. I didn't put gender in here, but we could put gender in as well. And then if the person is going to make, say, 12 ratings, then you'd have this line in here 12 times to fit into the model. Okay, so we have a hierarchical linear model. Here is the rating given by the respondent. It looks like an ordinary linear model, except that these are random effects, and then we model our random effects in terms of the context here. So the theta here is the parameter vector related to the context, and that's what we want to estimate. There's also that's called a hyperparameter. There's another hyperparameter here, which is the variance-covariance matrix for these random effects. And I'm not going to talk about estimating that today, but one can as well. Okay, so if that is not there, if the Zi is the identity matrix, then this is the linear mixed model. But we're taking a Bayesian approach, so we're going to put in some prior distributions on our hyperparameters and on our sigma squareds. And somebody asked the question just earlier of how sensitive the modeling is to the prior distributions. We actually did a big study in this model, and we found that actually this has got an identity, but you probably want to throw in some reasonable sized covariances to make it more robust to the actual situation. And that's what we did when we obtained our designs. Okay, so we're interested in hyperparameters, and today in particular just in the theta. We followed Challoner and Verdinelli's approach of trying to maximize the expected gain in Shannon information, which is actually this expression here, which is not a closed form, and you have to go through a series of approximations, which I'm not going to go through today. And you end up then with this criterion here. I'll call that the psi-I criterion, for want of a better name. If we're not in the Bayesian setting, if you get rid of the integrals and you put the identity in here instead of the context, then that's similar to what Rainer was talking about on Monday, is the mixed effects model D criterion. Okay, so we're going to use the Bayesian form, the psi criterion, for selecting a design. And what we're interested in is this level effect. This is what we actually set out to study in the first place. And the level effect, this is the definition. The addition of intermediate levels of a monotonic attribute increases the estimated contrast between the lowest level and the highest level part worth. So here's an example. Okay, so supposing you're going to show somebody a series of credit cards, and let's just focus on, say, credit limit, which actually wasn't in our study, but for an example. Presumably, most people would prefer to have a high credit limit than a low credit limit. And if we were to use the analysis to estimate the contrast between estimate the part worth, how much the difference in these two credit limits is worth to you, let's say we get an estimated contrast of 3.5 on a 10-point scale. Now let's put in some intermediate levels. Same three here, but push in here 2 extra levels. Amazingly, the estimate will increase. It may not increase by this amount, but it will increase. And that is called the level effect. And it's a very well-known phenomenon, both in psychology and marketing, and it's been seen to occur no matter what kind of measurement type you are using. Okay, so this causes a problem, because if you have a study and you're trying to work out whether credit limit is an important feature, an important attribute in people's choices of credit card, you do the study and you make your estimates of your part worths, 3.5. But then the person is actually going to select a credit card from the marketplace, and the marketplace is going to have maybe 10 different credit cards to choose from. So you want to be able to predict from your study into the marketplace. So what we wanted to do was actually try to model this level effect, because in the marketplace you're probably going to have a lot more choices than you do in the study. And so if we could model the level effect, we would have then some hope of predicting into different contexts. Okay, so I guess this is more or less what I said, but the standard conjoint analysis models without the matrix of context in it is not able to do that very well. Okay, so we had to model the level effect, so we went to the psychology literature to see what was there and what they knew about this effect, and we found two things. One's called the range frequency theory, and the other is called the distance density theory. Okay, so let me explain those. The range principle says the following. Okay, and let's, for sake of argument, say that somebody rates the lowest level as 0 and the highest level as 10, which of course they don't, but we'll worry about that later. Then this level here is 1/3 of the way up the scale. So the range principle says that the person would rate that 1/3 of the way up the scale, so 10/3, 3 or 4. The frequency principle says this is the middle level, and I should give equal spacing to my weightings, so I should rate this as halfway up the scale, the middle value. And then the range frequency theory will then try to put these two values together and essentially take a weighted linear combination of them. So here's the linear combination, here's the range value, here's the frequency value, here's the linear combination, and then here's some kind of a weight which says something about the scale that the person is using. Okay, if the omega is 1, that means people are using the range scale, which is this first one. They're doing a linear map. And if the omega is 0, then they're using the frequency scale and rating the middle value as halfway up the scale. So omega in some sense is the perceived effect of the skewness of the distribution of the levels. M is the perceived distance between the lowest and the highest level. So in other words, maybe you're not going to use the entire scale like that, and in fact most people don't. So let's either shrink or extend the scale. Well, that's where this distance density theory comes in, and what it actually says is the following, that if the region is more crowded, like here, in terms of your perception, it pushes the scale out. So what we thought we would do is model this M in terms of the number of levels presented to the consumer in the rating exercise. And we just took a simple linear model, so here it is. So here's the range frequency theory from the psychology literature. Here's the modeling of the scale parameter in terms of the number of levels, and then if you put all that together, you get this thing here as the perceived goodness of that particular level of the attribute. Okay, so we could do this with a credit card. You can see here 3 levels is coming in here. This is the, where are we? This is the frequency scale 1/2. This is the range value minus the frequency value. So what we want to estimate is actually this. This is the slope here for the level effect. And you can see that it's involved in a product with another parameter. So we have a nonlinear situation here. Let's go back a minute. So in our matrix of context, we've got f, the frequency value, the number of levels times the frequency value, the difference between the range and frequency value, and the same thing multiplied by the number of levels. So those are what's going in our matrix of context. That's here. And then, of course, we've got other attributes as well, like differences between providers, differences between offering travel points and not adding travel points. Okay, so in our actual survey, which I will show you in a few minutes, our parameters are the mean. Then these are the 4 parameters related to the context. Then this is the effect of the contrast between the 2 providers, the effect of the contrast between cash rewards and no rewards, and the effect of the contrast between travel points and no rewards. But what we want to estimate is actually these parameters individually, and so this is related to one of the things Rainer was talking about on Monday. We have to modify our criterion and put in these partial derivatives. So this is our final criterion for this particular study. Now we've got subscripts S here being different studies, and the reason is that in order to estimate the level effect, you've got to have different parts of your study with different numbers of levels, otherwise you can't estimate that slope. So we had to have at least 2 studies. And to estimate whether people are using the range scale or the frequency scale, you have to have unequally spaced levels, otherwise range value and the frequency value are the same. So we designed actually 3 studies. Each one had 12 profiles. To keep things simple, we had all subjects having the same design in the same study. And here are some details about the design. Looking around to see what was on offer, the credit cards available on the market, there were 7 interest rates, sort of ranging from 8.99% to 17.99% at that time. Study 1, we were just going to use the extreme levels of interest rate, plus the 2 providers and the 3 different reward levels. So that's 2 times 2 providers times 3 rewards. So there are 12 possible profiles, and the study is going to have 12 profiles. So this is a full factorial. In study 2, we took the same 2 extreme levels, and then we wanted to select 2 out of the 5 remaining possible levels of the credit card for 2 intermediate levels. So that gave us 24 possible profiles altogether. Given a choice of the 2 intermediate levels, that then gave us a choice of 24 possible profiles for the study. And so what we did was under our criterion, we looked at every possible matrix of context and then searched with an exchange algorithm for the best design. So that probably took a long time. My PhD student did that, and I'm sure Brad could do it in no time at all now. Okay, and then these 2 studies were used to estimate the level effect, and then the 3rd study, we wanted to see how good we were at predicting into a different context. Now, we are selecting our design, and the criterion is for estimation, not prediction. So, and nevertheless, we wanted to see how good it was for prediction. Okay, so there's the final selection of the interest rates in the different studies. This I know you can't read, but there are 4 designs. This is the design that's best under our Psi-I criterion, design 4. Design 2, we took out the context matrix and found the Bayesian optimal, d-optimal design just for comparison. And then we picked another 2 designs, and it would have been nice to have picked some designs that were very poor under the optimality criterion to compare with. But when you're using real people in a real study to get data for a Harris Interactive, you can't use really bad designs. So unfortunately, there's not a lot of difference between our designs. So here are the designs selected. We took design 1, which is just some miscellaneous design, as the baseline. This is the d-optimal design. So relative to the baseline design, it's got a high D efficiency, but it's got a low Psi-I efficiency. Here's the Psi-I optimal design. It has a high Psi-I efficiency and a low D efficiency. so we were particularly interested in these two designs because people tend to use de-optimal designs in the marketing field at the moment. Okay, so here is the survey. We started with 1,000 respondents and ended up with 757 valid responses, which was approximately 95 per version of the study. There were various rules. People had to be 18 or older, they had to live in the US, and they had to have a credit card already so that they understood something about credit cards. This, which I imagine you cannot read at the back, is to the introduction, telling them what the study is about, and also down here it's telling them what we mean by travel awards. Gives the card owner 1 point for every $1 spent, and a free domestic trip could be selected for as few as 8,000 points, depending on where you're going and who you're flying with. And then this is the top of the screen, and this tells them then what to do with their ratings, and that 0 is not at all likely to apply for that card, and 10 is extremely unlikely to apply for the card. And then, as I say, this was an experienced panel of respondents, and so they were used to doing this kind of rating exercise. That's the bottom of the screen. Okay, so we used the MCMC method to estimate the parameters, and using Metropolis-Hastings algorithm within a given sampler to generate the posterior draws, and here are the results. This is the parameter that we set out to estimate in particular. This is the level effect, so that's the slope of the line of how your utility or your perceived goodness of the attribute changes as you go from 2 levels to 4 levels of interest rate. And you can see all 4 designs are giving fairly similar values of this slope. This is the Psi-I optimal design. It's slightly higher here. But these are the standard errors in brackets, and you can see that, yes, the level effect is a real effect. The other thing of interest here is how people are using the scale. This omega is close to 1, which means they are using the range scale rather than the frequency scale when they do their rating. Okay, so how well did the designs actually do? If we look at the average variance of the estimates of the parameters, if you just look at the actual numbers, they're fairly close. If you take the ratio, then the ratio of the de-optimal design to the Psi-I optimal design, the de-optimal design is not doing so well in terms of the minimizing the average variance of the parameters. And how well did we do to predict into the third survey, which had just 1 intermediate level? And again, as I said earlier, I would have been a lot happier if I'd had 1 really bad design, so I could show you how good these designs were if you get the best designs. But they're not too different, the designs. However, this is our model in the top line here. This is the expected mean squared error of the mean rating predictions into that third survey. And interestingly enough, the third design, which is not best under any particular criterion, is doing the best under that, under the mean squared error. And then the Psi-I optimal design is the next best. So this suggests rather that if you want to do prediction, obviously you should have a criterion related to prediction rather than estimation. These other 2 models are models without the matrix of context and modeling the interest rate as a continuous variable, and we had to do that to get the paper published. And for each design, our model is actually fitting the best. Okay, so we modeled the level effect using the range frequency and distance density theory. We used a Bayesian hierarchical model and Psi-I efficient designs, and we verified that the existence of the level effect in our study. Future research. The other 2 speakers talked about choice designs and the nonlinear models, and marketing is moving in that direction towards choice and away from the ratings. So it would be interesting to extend this work to the choice designs, and we have been talking to Brad about that possibility. We've also been talking to Brad about the possibility of having customized studies for different groups of respondents, because as he demonstrated in his study, if you get different demographics, then people are going to give different kinds of ratings. So it would be nice if we could find the demographics of the people in the study and give different designs to the different people. Or maybe if we have a big panel, how do we actually select the respondents for the study? So that's, if we've got demographics in our context matrix, we need then an optimal design, not just for which questionnaire you give people, but also for which group of respondents you're going to pick. And then, as I mentioned earlier, it would be nice to actually have a design criterion focused on prediction if you're going to predict into different studies. And I think I'm right on time, right?
So we have plenty of time for questions.
So you used panels of expert assessors. Are they going to be typical of?
Are they going to be typical? No, they're probably not going to be typical. And then you've got to worry about how many products can a non-expert reasonably rate. So if you've never done this before and you're presented with 12 products to rate, that might be a bit overwhelming. You might manage 6, I would think.
I'm thinking about drawing inferences for a wider population based on this very select kind of.
Well, yeah, well, that's true. But that's how the opinion polls work. They have these panels of people that do, I mean, otherwise you've got to have some kind of sampling frame, and you've got to be able to select people from your sampling frame. I mean, how do people do studies? They use their students in their classes. They use panels that are out there. But I mean, you're right. You've got you do have the problem of predicting outside.
And when they're scoring on a rating from 0 to 10, do they tend to come up with integer responses?
In this particular study, I think we did ask for integers, yes. So, you know, you could have a wider scale, because we modeled it with a normal distribution, even though it was a 11-point scale if you count 0. And of course, people don't use the whole scale. This is another thing. They may only use the part of the scale from 5 to 8, and even if you give them a 100-point scale, they may only use a little tiny part of it. So there are those problems as well, and I think that's maybe why the marketers are moving towards these choice experiments, because that gets you out of that problem.
When you evaluate the efficiency of the different designs, provided that you did a Monte Carlo sampling of the posteriors, wouldn't it be better to look at the variance of the posteriors as an indicator of quality rather than the variance of the estimators? Like you want a small, peaked posterior.
Yes, yes, yes.
And you can have that as an
Yes.
indicator of the efficiency rather than
Yes,
some more indirect criterion on some estimator.
yes, yes. That's a good idea. We didn't do that. These are obtained through the Monte Carlo integration, actually getting the estimates and then calculating the variance of those. But yes, you could do. Isn't it the same? It's probably the same.
Depends on what you mean
Yeah.
by the variance of the estimator.
Yes, yes. Okay, I'll talk to you afterwards. The answer, I mean, I have to find out the details from my PhD student, precisely what she did. This is what she gave me.
Okay, then to conclude this session, let's thank all 3 speakers again.